Hello everyone, welcome to this 6th week of the course on Introduction to Modern Applications Development. We have come almost halfway through the course. Last session we saw how to create a very rudimentary web application. In this session we will look at the basic aspects of including a database in our web application. The plan is basically as follows. We will look at the idea of preserving state. This will take us back to our very first sessions. We will look at some basics of setting up MySQL, which is the database that we will use. And we will also look at how to use JDBC in order to use the database that we set up. Let's take a look back right from the beginning at what we have done. We started with actually a spreadsheet that implemented the basic algorithm of our solution. We then went on to create a non-interactive command line Java application that implemented the algorithm in Java. The non-interactive meant that all information required for execution of the program was given before the program started. Our command line therefore looked like, for example, fair share, register friend1, friend2. Another invocation of the command could be fair share expenses by friend f2 of say rupees 200. A third invocation of the command would be fair share report for friend f1. These were three distinct invocations of the command, and at every point, at every invocation, we gave all the information required to execute that. We then went on to create a command line, but an interactive version of our program. Oh, but before that, when we had a completely non-interactive version, command line version of our program, we required some mechanism to remember what the previous invocation of the programs have done so far. So when, for example, our current invocation was to request a report for say friend f1, then somehow we had to remember what the previous invocations of the fair share program had done. And at that point we had used a file as a way of remembering the information across various invocations of the program. In contrast, when you take a interactive command line program, in an interactive command line program, we are going to give a sequence of commands which together represent an entire interaction by the group of friends. So after starting our fair share program, we had a sequence of commands: register f1 f2, expense f2 200, report f1, and finally a new command end, which told us that there are no more commands coming. Once all the commands were received by the fair share program, while it was running, it processed each command individually as before and gave output as required. So finally, for example, if report F1 was supposed to be given out, the only thing that the command did was to show what was the money that was either owed or to be received by friend F1. That is all that happened. Contrast these two interactions, the non-interactive command line part and the interactive one. The interactive one really did not require any external mechanism to remember what was happening. Every invocation of the command was self-contained. It started from the beginning of the interaction of the roommates right up till the end. The entire sequence was done in one go in the interactive version of our program. In such a scenario, there is no real need to remember information across individual commands, because that is anyway a part of the entire program. However, just as we said a couple of moments ago, in a non-interactive command line version of the program, we would need an ability to remember what previous invocations of the command had possibly done. Well, we will now come back to that situation in a short while. But continuing, after the interactive command line version of the program, we then graduated to decoupling the input and output from our processing, the view and the model part, as Professor Sane would have put it. We did that in two stages. We first changed our interactive command line version to produce an HTML page as an output. So what earlier was simply an output on a terminal was now a HTML page, which could be displayed anywhere on the internet. The next phase was to introduce the ability to acquire input via HTML. This generalization gave us our very elementary web application where the input was on some node on the internet. Similarly, the output was on some browser on the internet, and the processing was done on our server. So on the browser of the user, you had a form on which commands were typed. These commands were sent to the server. The server actually had our command line Java program, or the interactive version of our Java program. It simply picked up those commands, executed them just as before, produced an HTML output which was returned by the server back to the browser that requested it. This completed the whole basic cycle of a web application. But then the problem with this has been that it is using a forms interface where the entire bunch of commands is given at one single piece of input to the model or the Java program on the server. It was a command line interactive program. What we eventually desire is to have individual commands being sent to our server, which will perform the fair share computations as required by the command and return the results, if any. In other words, what we really want is the input and output separated as before using HTML, but the model or the program that runs on the server, we actually want it to be a non-interactive command line program. Each request from the user, whether it is a register or an expense or a report, is an independent request being sent to via the web to our fair share program running on the server. The fair share program will execute each request and keep on and go on to the next request. Because conceptually now our program is going to be invoked for every individual request, on the server side we are really thinking of multiple invocations of our fair share program, but with different commands at each invocation, exactly similar to our non-interactive command line program. Therefore, just as before, when we argued about non-interactive command line programs and we thought that we needed a file to remember whatever information was processed in the previous invocations, in the same way we will now need to do that on this web application system. It is for this that we use databases. In the next few slides, we will again jog our memory a little bit. Here is our first one, the spreadsheet. Observe that it's just laying out data in rows with individual columns talking about individual friends and their expenses or per head share calculations. This is the command line, the sketch of the command line application. In particular, we want you to recall this part where we said that we need to write to the backend storage, and this was some data storage in secondary memory. At that point we had said we will look at databases when we come to that. Well, we have arrived at that point where we now need to consider databases. At that point we had said that we would simply use a file. In that file also our organization was very similar to the spreadsheet. Each row represented an event. There was input data for that event, and there were per head share calculations for that event. So we will now use MySQL as the database system that will work along with our HTTP server, and we will interact with the HTTP server using the Java Database Connectivity, JDBC. In the next few screens, in the next few slides, we will see a few basic ideas about what is required to get a MySQL database working and a JDBC system working. These are bare minimum some important points that we observe that you could possibly need. But a full discussion, we suggest you look at the documentation of MySQL or JDBC that comes along with your software. A typical MySQL setup would of course be dependent on your particular OS and has to be done accordingly. Or you may use XAMPP as suggested by Professor Sane, which is a overall system which has MySQL and a lot many other pieces of software typically useful for web development. But it is supposed to be a development system and not a production system. So XAMPP we suggest you use for learning purposes. The key things that you need to ensure as far as MySQL is concerned are that it does not skip networking, at least until the point you understand how to create a very secure MySQL system. You will need to ensure that you have created a database called fair share. We will shortly show an interaction sequence. You also have a user with all the required privileges. In our example, we will be using NPTEL at localhost as a user, and we would have granted all the privileges that are required. Let's have a look at a basic sequence of interaction with MySQL. This interaction will set up MySQL for use with our fair share application. Here is a screenshot, a screen record actually, of our interaction with the MySQL system. This illustration is based on XAMPP that has been set up on my personal web machine. We start with the command bin/MySQL, and voila, that's where you see. Show databases is going to show the set of databases that are available at this point of time. We create a new database as follows. Create database fair share v1 for version 1. There you go. We now create table within that database. This table will assume that there are two friends. So event number is an integer. Expenses for friend F1 is a double precision 10 digit with 2 decimal digits number. Expenses for F2 is again a double precision 10 digit 2 decimal places number. Per head share of F1 and per head share of F2 are also double precision 10 digit 2 decimal places numbers. This is the way one creates a table. You could create as many tables as you need. Voila, we forgot to select a certain database. We do that by using the command use. Having done that, we can see that the create tables has succeeded. How do we see that? The show tables command shows us. Now we can select all the entries from the events table. We do that from using select star from events. But then there are no entries so far. How do you insert an event? Well, you insert into events values, event number 1, expenses by friend 1 200, expenses by friend 2 0, per head share of F100 and per head share of F2 is -100. And when you now select star, you can see them. We change our SQL database to MySQL and look at the users table. We want to create a user NPTEL at localhost whose password, or that is the identification system, would be NPTEL. Notice that we have made a small mistake. Well, it's if one looks at it closely, it is really just the spelling mistake. Instead of identified, I have mistakenly typed it as indentified. Fortunately, MySQL has told us an error, that there is an error in the SQL syntax. And having observed that error, corrected it, this is what happens. A new user NPTEL has been created successfully, and we can check that again by performing a select on the user table. There you go. Now you can see the NPTEL user. This user also has to be granted the required permissions, which we have not shown over here. Let's have a look at the database. Let's have a look at the table. Let's have a look at the table. By the way, MariaDB is the same as MySQL for our purposes. So although the prompt that you see is MariaDB, think of it as MySQL. It is a very text-driven system. We are showing a screenshot of a query select star from events, and there is one event that is shown over here. What we saw in the interaction sequence just now was a very interactive manual creation of the database, the tables, the entries within the table, and so on and so forth. What we really need to do is to perform some of these tasks via a Java program. So our Java program will receive commands over the web, execute them, compute whatever information is necessary, and then use the database to store information. So our Java program will need access to the database, access to the particular table within the database, and the ability to manipulate that table, that is the rows and columns within that table. What we see here is a table with one row. The table itself with integer event number, double precision, 10-digit, 2 decimal places, expenses for friend F1, etc. The table itself is created when you give the register command. In the response to the register command, our Java program via the JDBC system should create an empty table which has the event number, expenses for each friend, and per head share of each friend. This creation of the table is done in response to the register F1 F2 command. We already saw how to create a table manually. These columns are expenses for F1 and F2, and these are per head share columns for F1 and F2. Note that the number of columns will depend on the number of friends that you have requested for registration. An event is inserted. We have seen the manual insertion before. In fact, via Java, we will actually use the same command and give it to the database, except instead of giving it manually, we will construct that command through Java and pass it on to the MySQL database system behind. That essentially is all that Java and database systems require to work together. Finally, observe that this table actually looks like a spreadsheet. The views are very, very similar. Here are some notes about the basic steps, basic issues, basic points to remember when you are using JDBC, that is Java Database Connectivity. In order for Java programs to interact with MySQL, we need a piece of software called as the driver, that's usually called as ConnectorJ, J for Java, and this is available on the MySQL website. In these slides, I forgot to include the URL for obtaining ConnectorJ, but in my subsequent slides or with Professor Sane, we will share the actual URL with you. But it's very easy to find that over the web. Install the ConnectorJ system as prescribed by your operating system and ensure that the class path is set correctly. The ConnectorJ essentially is a Java archive, a jar file, and that jar file must be put into the class path so that it's accessible to Java programs. Okay, let us now go to the final part of this session where we look at how to actually write Java program that interacts with MySQL. Let's start from our command line, the sketch of the command line system, and with a particular focus on data storage in secondary memory. In the earlier session, it was just a box, which was a conceptual box. It just represented an idea, and we now want to implement that idea, realize it in practice. So what we do really is use the JDBC system to interact with the database. Our Java program, the command line Java program, will use Java database API to connect to the MySQL database and use that connection to retrieve or store information into the database. It's conceptually that simple. Let's have a look at the actual Java code that can will illustrate how a Java program interacts with a MySQL database. At this point, we will assume that there is a MySQL database that has been appropriately created. For example, in MySQL, there would be a fair share database which has an events table. Okay, and there is a user NPTEL with appropriate permissions. All privileges that are required are given. In what follows, we are going to make these assumptions. To connect with SQL, you need to import some packages as here. Let's start from the beginning of this program. This again is let me state this again. This is a illustration of a procedural style of using Java. There is no object-oriented programming here. This is just a procedural style of using Java. So our program starts with main, and the first thing it does is it connects to the database using the FSDB object. The FSDB object is a class variable over here. It is an instance of the example JDBC implementation, example JDBC class. Here is the example JDBC class. It also includes the packages required for doing connecting to databases, in this case MySQL. And there are a bunch of methods over here which will be used as the methods of the FSDB object. That is what we do here. Having instantiated that object, the first thing we do in main is to connect to a database. Once the connection is done, further operations can be done. For example, you might want to do registration. This is actually the same code as before, something that we have already seen, except now it has been changed to include JDBC. Recall that when we register, we actually create a new table, because at the point of registration we exactly know how many friends are there in the group of roommates. So the table command, create table, the name of the table is events for us, and the various fields of that table, event number being an int. Note that this is a partial string, partial command. although it's a complete string, it's a partial command. And as we go process the registration part, we are going to add to this string, and therefore at the end complete this particular command. So as a part of doing registrations, we are building the command piece by piece that is going to construct the table. So as we have found a number of roommates, for every roommate you are going to add expenses for that roommate, which is represented using a double precision 10-digit 2 decimal places number. This is in a loop. So as many friends has been requested, that long table will be created. But this is just the expense for loop. You will have one more for loop. Which does the per head share, which creates the per head share field. These data structures are as before. And finally, the table command is completed. The entire construction of the table command is complete. Once this is done, you can now use the execute MySQL command method of the FSDB object, which is an instance of the example JDBC class. Here is how you would execute a MySQL command. We will ignore the query mode for a moment, but here is the string. The command is expecting an entire SQL command. Create table with whatever event number as integer or expenses for F1 as double precision 10-digit 2 decimal places, and so on and so forth. These messages are to trace. These messages are to trace what is happening. The way a command is executed is you use the create statement method to create a SQL statement, and within that SQL statement you execute the command, the string, whatever is it. In this case, the command is to create a table. That is what is happening at this point. It's a new table command that is being executed. So we see that the basic interaction with MySQL database via JDBC is very simple. You connect to a database, start executing the individual SQL commands. How do you execute individual commands? While processing the data, construct the SQL command piece by piece until the entire command is complete. Once the entire command is complete, use the JDBC interface to execute it. This is simply a method that we wrote, but these are the methods. You create a statement and execute it, either as a query or as a command itself. The same thing will be done for, say, expenses. In an expense command, we need to insert the record of expenses. That record is fortunately available in the make record method that we had written in our very first program. A slight modification of that would involve adding an extra variable that helps us to construct the insertion of that event into the database. So insert into the table values that have been found or processed for that particular event. So to the event insert command, we will simply concatenate the individual pieces of information. There you go. And finally, we will execute that insertion command using our method as before. We can do this for even report generation. Let's see that command in action. We will first see these two files, the Java source files, as a part of our simple listing of files to convince ourselves that indeed these files exist. We will then use the Java compiler to compile them. We can compile both of them in one shot, and we will get individual class files. We will see that these class files indeed exist. There you go. And now we will run the fair share program via the Java interpreter. But wait, we need to see the input. So for the moment, we'll comment it and simply look at the input, which is very much what is expected, what is obtained by our command as a result of a HTML interaction, as a result of an HTTP interaction, the so-called post interaction. That is what we see here. And then of course when we run Java, when we run that program, we will see the result of interacting with the MySQL database. This illustrative program is by design incomplete. It only gets you started. It, for example, does not show how do you update a certain field of a given event, which of course you would need in order to say update the various the per head share of individual friend if need be. Or how do you get the values of a friend, the per head share of a friend, and sum them up so that you can report for that friend. Those details are not included in this particular example, illustrative example. They are for you to work out. That is all that we have in this session. In the next sessions, we will go on to servlets. In the meantime, please extend your initial Java program so that it can do interact with a MySQL database. Please set up MySQL and JDBC so that these things work. Thank you. See you in the next session.